Welcome back to day 18 of Advent of Code 2024. Today we have a list of inputs. This is a list of obstacles with coordinates x and y that we will need to put in our grid that in the example should be 7 by 7, so 7 wide and 7 height. The start index is 0 and index is 6. We start at index 0. We should apply 12 obstacles into our grid, and we need to find a shortest path to arrive at the 6,6 point. It would take us 22 steps, and in the real example we need to apply 1024 obstacles in our grid and find the shortest path for it. For the part 2, we need to find obstacle that will block our shortest path so we can arrive at our destination at 6 or 70 in the real example. So we need to find the first obstacle that will block our way to get to the endpoint. So for the implementation, I read the data first from the file, then I parse the lines. I split the lines I take the line and split the data at the comma sign, so to get these two integers. Then I parse it to integers and pack it into a tuple and then append it to a list. So I have a list of tuples with two integers for each tuple. To organize the code, I created a class called simulation. I pass in the size of the grid, the parsed data, the start position and the end position. I also store the already simulated bytes as a class field and store all the data that was passed, so the width, the height, the byte locations, byte count, and start position, end position, and at the end I generate a grid. So to generate a grid, I just iterate over the range, which is the height of the grid, and for each row I generate list of strings, which is just a dot to symbolize an empty spot. So in the part 1, I call the simulate bytes, and simulate bytes iterates over the slice of byte locations. So it takes the value from simulated bytes field, which initially is 0, and takes the end index, which is the simulated bytes plus the count we pass to this method. So it takes the slice beginning from this one and adding the offset of count. And for each obstacle will be applied to the grid at the row position and the column position that is defined in this list. So we updating the grid with obstacles, and to get the answer for part 1, I call the find shortest path method. The find shortest path uses Dijkstra algorithm to find shortest path. So I initialize a distance map, which is a default dictionary with float values with infinite value for each data point, and then update the start position, which has distance 0, and then I iterate and update the distance from the start position to each other point. So I skip the out of bound and also skip the points that are the obstacles, because we can't cross the obstacle, so we need to find another way. And here we updating the distance for the point that is valid. At the end, I output the distance value for the end position from the distance map, and if I run just the part 1, it should output the value. It's 446, which is a valid value. For the part 2, basically I use the same methods and everything. I just go and try to set new obstacles and calculate the shortest path and check if the path cost is infinite or the end position. and if not, I apply another obstacle and continue with the computation. So I check for every single obstacle if it blocks the path, and if it is so, then the distance will be infinite, and then I output the last obstacle that blocked the path, and I output it as x and y value. So this is 39 and 40 in my case. So that's it for this video. If you enjoyed, leave me a like and a comment. Thank you very much for watching, and until next time.